Connect to my machine. Right. Now, so now, uh, so Monishika, you can go through those videos after that class, which happened last week when you attended that, right? So after that, there are some couple of lectures has done related to the. I think after that, only one lecture, is it?
Yes, sir. Only one lecture yesterday, which
Oh
you told
yeah,
me.
Monday, Tuesday, Wednesday. Oh, only one lecture. So Monishika, then just go through that. There we have discussed that how you can push the file to the Docker Hub,
Okay.
and what else? To private registry. So those things we have discussed. Just
Okay.
walk through that. Video is already on the YouTube. All right. Now today we will talk about the you know few more things. We are almost not completely and but 70% of Docker is discussed. Now, let me talk about the storage. Okay. So what is storage? So when we are talking about the when we talk about the storage, right? So storage is very important part. See, whenever you are um, basically talking about the storage, let us first understand. Let's first understand what is the meaning of storage here. See, whenever we are having a consider this is your system, right? So this is your system, and on this system you are having a container. Okay, so this is the container, right? And now everything is inside this container. What it means? It means that, um, for example, or let me just have another. So everything is inside this container. So it means if this container is deleted, okay. So if the container is deleted, if the container is deleted, then what will happen? Whatever the data inside the container, that also get deleted, right? So whenever the container get deleted, then the data inside the container also get deleted, which is not a good idea maybe at this moment. If we when we are talking about the container, right? Container is having our application. For example, you are having a Python file or jar file. You put it into your Docker image, and through Docker image you have created the container, and now container is running, and you are expecting that I will store the data inside the container. But that is not a good idea, because not at this moment, but later you will see when we will talk about the container orchestration, where we manage the containers. Okay, and we are applying replication. We are, you know, we are having a cluster, and on cluster our containers are running. And you will see that containers are very frequently get deleted. And if I store everything inside this container, which is my persistent data. Persistent means the data which you want to preserve. You want always, right? So if that get deleted, then it's not a good choice. See, Google, Facebook, Chat GPT, everything is running on the container, and AWS, Amazon, right? So I have already shown you that in a day there are many implementation, and containers are keep getting deleted. New containers are getting created, and there is no downtime also, right? So if we say that we will, you know, um, if we say something like this, that if the container get deleted, then if my data get deleted, it's not a good idea. So what you need to do in that case, right? So in that case, we will do something else. We will we will be having two types of containers. Okay, two types of storage inside the container. Number one, temporary storage. Means if my container get deleted, then that my storage, whatever the data we are having inside the container, that get deleted. So this is further of this is called persistent, non-persistent storage. Okay, so this is called non-persistent storage. Now let us first see the default behavior, how this container or Docker container keep that data, how long it keep the data, and then we will discuss about the temporary file system. Now, if you are thinking that if my container get deleted and my data get deleted, then what is the use of the non-persistent? Not required, right? But no, there are many cases where you want to have the non-persistent data. Let us talk about the session, right? For example, you are having the HTTP session, right? And you are connected to your web application. When you log out or whenever there is a disconnection happen, right? Your session data is deleted, right? That is, um, if you don't want to preserve that, in that case, you can have this non-persistent data. Second, for example, you want to perform certain in-memory task. For example, you are doing some calculation, right? So that calculation, when you are doing after that calculation, you don't need it to be saved on your disk. So in that case, we go with the temporary file system or the temporary storage. Okay, so let us see how non-persistent works. So for that, what I'll do, uh, I will go to my machine. Let me clear the history. Now, first we will see the storage part we are talking about. So first we will see the default storage of the container, right? So what I'll do, I'll see is anything running. There is one container running. Let me delete this docker rm-f and private registry. So I have deleted this container. Let me see, is there any image I have? Docker images. I will remove all the images. Docker rmi-f dollar and docker images minus q. Right? So all the images will be deleted. Now, if I say docker images, yes, there is no image. Now what I will do, I will say create a container, docker container run minus it. Name of the container, excuse me, you can give anything, my container, right? And I'm using Docker image, say Ubuntu. Okay. So what I'm doing, I'm creating a Docker image called Ubuntu. Now Ubuntu container get created. to double check, docker ps list all the containers. Right? There is one container which is my container and it is in the up state. Okay, this is the container ID and 8 seconds ago it got created. And remember, we have discussed in the Docker file command and entry point. So this is what written in the command of this Docker file, which is Ubuntu. Now, what I want to do next, I want to go inside this container. So I will say docker exec -it, container name is my container, and I want to create a directory, for example, or yeah, I want to create a directory mkdir, and I want to create a directory called test directory, and that directory I want to create it under the root. Okay, so now this is created and this is created inside the container. Now if I say ls and so here the directory is the test directory, right? So here is the test directory get created. Now what I will do, I will go in this directory and I will create a file. Okay, so I will say uh, touch will create a blank file under root test directory. I want to create a file, say test.java file. Okay, so this is created too. Now if I say ls and under root test directory, so you can see, yes, there is a test.java file, right? So what I have done, I have created one container. Inside that container, I have created I have created one file, one directory called test.java. So now next is that I want to stop the container. Okay, so let's stop the container and see that, or you can say let's restart the container. Let's restart the container and see the storage, or more explicitly, if I say the test directory / test.java file is available or not. After that, okay, so we'll see. So what I will do, docker restart, and my container name is mycon. So I'm restarting the container. So it will stop the container and start it again. Right, so it is done. Now if I say docker ps, so you can see, yes, container is updated, means it is restarted 11 seconds ago, right? So now what I will do, I will go inside the container and I will see whether this directory exists, test.java exists. Yes, it exists, right? So what I have done, I have stopped the container. After stopping the container, what I have done, I have just checked whether that directory and file exists or not. So it means the default behavior of the container is that if you stop the container and if you restart, right, so it will not delete your data. So this is, you can say, persistent. Okay, this is persistent. Now what I want to do, I want to delete the container. Now I will say docker rm -f and my container. So when you delete the container, now that data will be deleted. So in this case, this is non-persistent. Okay, so when we delete the container, then the data inside the container also get deleted. Okay, right? So that is uh, the purpose of this default, or that is the behavior of the default behavior of the container to keep the data until unless you delete it. So there is another type of the non-persistent, which is called temporary file system. So it stores the data in memory. So what it will do, it will store the data in memory only of the container. So it means if we stop the container, so then what will happen? The memory will be flushed out, right? And when we start the container, that data will not be there. So when we stop the container, the data mapped to temporary file system will be deleted. Let us see. So what I will do, I will create a container now. I will say Docker container run -it. Name of the container, you can give anything. I'm giving my container. And here I need to use a option which is called mount. And here I will say type equals to temporary file system. And you need to mention the directory. It is not applied to an entire container. You need to specify a directory inside the container, which is a temporary file system. So I will give any directory, say my directory. If this directory does not exist, it will create that directory and then apply the temporary file system storage on top of that. So here, then what I can do, yeah, then I will use the Docker image ubuntu. Okay. So my container get created with temporary file system. You can also inspect. So if I say Docker inspect my container, so I can see that there will be a mount. Here you can see mount is basically indicates the storage part only. So here it is saying there is a mount, which is the temporary file system, which is attached to your container. And the destination directory is my directory. As I mentioned, this is the directory which is inside the container. And if this directory does not exist, it will create that directory. And if this directory exists, then it will be mapped to the temporary file system in this case. So what I'll do, I will go inside my container. I will say Docker exec -it. My container name is my container. And here I will say ls is my directory exist. Yes, there is a directory. That's why it did not return any error. Now I want to create a file inside that. So I will say touch, and under that I want to create a file called temp.java file. Right? So file is created. Now if I say ls, so you can see inside my container there is a my directory, and my directory is having temp.java file. Now what I want to do, I want to restart my container. Okay, so let's restart the container and then check that temp.java file exists or not. So what I will do, Docker restart and my container. So I'm restarting the container. Okay, so it is restarted. You can say docker ps. So you can see just now it got restarted, whereas it was created 2 minutes ago. Now, what I will do, I will run the same command. I want to ls. See, temp.java file is deleted, right? So it means the data which is inside my container that got deleted when we restart the system. And this was not the default behavior of the container. We restarted our container earlier, and that was uh, that did not delete the data. But when we delete the container, at that time that data got deleted. But in temporary file system, if you use this type of storage, then basically what it does, it is even though when you restart your system, not system, the container, right? So it removes that data. Okay, so this non-persistent, as I mentioned, it will be used in those cases where you are having a uh, session-based data, temporary data, which you are not bothering that, okay, if it get deleted when container get deleted. In those cases, it will be useful. Okay. So now I'll delete this container, docker rm -f my container. Do you understand the purpose of, or what is non-persistent container?
So, and so what are
Yes.
the size? What is the size of this non-persistent file?
There actually here we don't mention the size. Size we can mention. There are some options. That's a very good question. So let me just go to the Docker size, right? And for temporary file system. So here we can specify the size also when we are mounting. So here you can see that Docker run, and this is the mount path. So there is a option of the size. Specify the size of the, like you can mention hyphen size equals to like 16 MB, 64 MB in this case, right? So here you can see Docker run, and you can means here see this command is different from the one we have discussed. It is actually not different, it is similar. This is the another syntax you can say, right? So here what it is doing, temporary mount feature is available in, yeah. So here we can specify the size. So here I have given you this, I have shown you this particular way to create the temporary file system. Type equals to temporary file system. You can write in this way, or you can create with this way also. Docker run temporary file system. Okay, and this will be my directory. Okay, and size is 1024, and on this directory I want to, means data is the directory, and I want to give this mode 777. 777 means that is basically your all the permission, read, write, and execute permission, right? And here you can see no execute, does not allow the execution of executable file in mounted system. So it means it is not used for that. So you can use these options. So let us try this. Let me copy this, and okay, Docker container run. Yeah, this is the right way. Docker run the way I have shown you, right? So we'll take this example actually. So this is incomplete example. Docker run mount type is temporary file system. Destination is some directory. Size is in the bytes. We'll just make it less. And mode is 1777. There are still so many things are missing. Docker container run -it. Name of the container, I will say C1. And the Docker image is also missing. So I'll say -t and ubuntu. Okay, so this way we can specify the size also. Understood? This is the size, this is the permissions. Right? So it is always suggestible that whenever you are doing a practice, better to come to this documentation. You will find a lot of examples related to that. Now, let us talk about the second type, which is basically your, which is nothing but the persistent volume. So first type of persistent volume is Docker volume. So this is the persistent volume. Persistent volume means if we delete the container, then my data will not be deleted. So Docker volume is maintained by Docker daemon. So Docker daemon is maintaining it. Docker daemon is nothing but the service which is running under the under the Docker engine. Now what it will do? It will so what it will do? It will basically persist your data. It will share one directory with you where it will keep the data, right? And because it is maintained by Docker daemon, so Docker daemon is having certain commands related to the Docker volume. So let us do one thing. Let us run this and see. So now what I want to do, so so what I will do, I will create. Let me delete this container Docker and rm -fc1. So let me delete this container. Container is deleted. Now what I will do, I will say Docker and container run -it. Name of the container, I will say C1. Okay. And I want to use the mount option. And before that, let us create a volume. So Docker volumes, Docker volume ls. So there is one volume get created already. So sometimes, so this is the anonymous volume, unknown volume, right? Which we have not created. So if I say Docker and volume and --help, so you can see there are some commands related to that Docker volume: create, inspect, ls, prune, rm, right? Now what I want to do, see this prune command, remove all unused local volumes. So if this volume is not in use, it will be removed. So let us see how we can do that. If I say docker and volume prune, so it is saying, shall I delete the unused volumes? Yes. So see that volume get deleted. Now, if I say docker volume ls, so you can see, yes, there is a volume get deleted. Those volume get deleted, the one it was showing, it is deleted. Now I don't have any volume. Now there is a special directory which is where lib docker. So this is the directory where all the Docker related stuff is available. For example, if you see here, containers. So all the container information is here. Docker image information is here. Docker volume information is under this directory. Now, if I see what is inside the volumes, so you can see at this moment there are two files, metadata.db and the backing file system block dev, right? Now, whenever I create a Docker volume, by default, it get created under this particular directory. Let us see. So Docker volume and the command is create. Docker volume create. So for example, I want to give the volume name as demo volume. So now this volume get created. Now where it is created actually, it get created here. You can see there is a directory get created under this particular volumes directory with the same name as my volume name. If I say Docker volume ls, so now you can see there is a local volume get created, which is the demo volume. Now what I want to do, I want to check what is in the demo volume. So there is a directory which is called underscore data. So that directory is there. Apart from that, there is no data inside that. Now what I will do, I will attach this volume to my container. So I will say Docker and container run -it. Name of the container, I will say C1 or yeah, container C1 or C2. I think I have deleted that, but C2 container, right? And I will say mount. And then I need to provide the source. Source is your volume name. So this is my source. And then the destination. Destination is a directory inside your container. So I will say demo directory. If it does not exist, it creates that directory. And then I will use the Docker image, say Ubuntu. So now my volume is attached. How do you know? You can run a command docker inspect and your container name, which is C2. Now here, if I go to the volume mount option, right? So here you will see that type is volume and the name of the volume is demo volume. And as I mentioned, this is the directory, right? And destination means inside your container, it is mapped to this directory. Now what I'll do, I will go inside my container, docker exec -it. Container name is C2, right? And I'll say ls/demo. There is nothing inside this directory. So what I'll do, I will create a file. Under demo, I want to create demo.java file. Now if I say ls, so you can see there is a demo.java file. This file is not stored inside the container actually. This is stored in the same this directory. And this directory is on my local system. So demo.java file is actually gets stored here, but it is when you go to the container, you can see this data because when I have executed this inspect command, so here you can see that I'm having read and write access. So here you can see type volume this and read and write access is straight. So I can create a file from my container and I can delete, I can read All those things I can do. Right now, it means if I delete my container, if I say docker and rm minus f, my container C2, so I have deleted the container, but my data is not deleted. My data is still there. So it means if I create a new container now, right? As an example, you can give any name. Consider I'm going to use CentOS 7 image, right? So now it's a totally new container. Destination directory also you can change, but the source volume I'm keeping the same because source volume is pointing to this particular directory, right? So it means now I'm creating another container and which is of same image or different image or compatible image to that. Means if it is Windows, then Windows only because file system is different, right? So here CentOS and Ubuntu file system is same. And now if I run this command, right? So my data was there and right, and see in the C2 container, I can have this demo.java. So it means even though I have deleted my container, but my data did not get deleted. So this is the example of the persistent volume. Do you understand this?
Yes, sir.
Hmm? Just give me 1 second. All right. Right. So now see, um, the main purpose was that we need to we need to have our data available. Right now, consider that you are having a container, MySQL container. Okay, and data is everything for the company, right? So storage is very important. So here your web application is one container and MySQL is another container, right? So this web application is storing the data into this MySQL container. Now you have deleted the container. If the container is deleted, then the data files and the transaction files, right? So everything get deleted, right? So data files and transactions files are deleted. If these get deleted, it means your data is still deleted means not good. So that is why in that case, we use the persistent volume. So I have shown you that there is a demo.java file I have created. But when I deleted that container, my data did not get deleted, right? So that is the purpose of the that storage. Now let us talk about another type of storage. Now few things you need to try by yourself. First thing, you need to, or let me write down here instead of, so these things you need to try by yourself. Number one, create 2 volumes. Okay, named it as demo volume and say demo 1 volume. Okay, and you need to attach to a single container. This you need to try by yourself. It means you need to write 2 times hyphen mount, and then uh, you know this volume names and their source and destination, single container. Second thing, what you need to do, uh, second thing is that create a volume and attach to multiple containers. So that is possible. Single volume you can attach to multiple containers and observe the behavior. Observe the behavior means you need to uh, check if I go to container 1, container 2. So whether for example, container 1 creates a file, so that container 2 should see that file also. Okay. So those things you need to try. Let me give it on the chat window this. Right. Now, next thing is that you can create a read-only volume also. So far we have seen that volume is having read and write permission. But I want container should not able to, container can read the volume but cannot do the write operation. So for that, I will say docker container run -it. Name of the container is C3, and I will use the option which is mount, and I'll say source equals to say demo volume and destination some directory, say /app directory inside my container, and then you need to write read only. So when you write read only, then this volume will be read only for the container, and I'm using Docker image say ubuntu. Okay, container get created. Now if I say docker and inspect my container C3, right, so here you can see read and write is false, means you cannot do the read and write operation. You can read, but you cannot do the write operation. So let us see. If I say docker and exec -id, and the name of the container is C3, and if I say ls and under root app, there will be demo.java. Now I want to create one more file under this app directory, so it will not allow me. So if I say touch and demo1.java, because I only have the read-only permission. So this way you can give the read-only permission. So this is one type of the persistent volume, right? Another type of persistent volume is called the bind mount. Okay. Another persistent volume is bind mount. So what is bind mount? Now see here what I have done by default, what Docker daemon is doing. Docker daemon is maintaining this volume into a special directory. Now you want, okay, if I use the Docker volume, then what it will do? It will create the volume, but most of the things are managed by the Docker daemon only. Instead of that, a system administrator should maintain those directories. For example, I want to create my own directory, say my directory in some folder. Here I want to apply the size. I want to apply the permissions. I want to do a regular something cron job I want to run. So in that case, this uh, this my directory, right? This is my directory, means I have created this. It is not under var lib, docker, volumes, right? So if you have such kind of requirement, your own directories to be mapped with the containers directory, right? So then you can use this bind mount option. Let us see. So what I will do here, I will first delete my containers, docker rm minus f and docker ps minus a minus q. So it will delete all the containers. Now docker, what I will do, I will create a directory, mkdir, create a directory, say my directory. And I will map this directory to my container for persistent volume. So what I will do, docker container, and let me remove that volume also. So when you delete the volume, then the data will be deleted as well. So if I say docker and volume rm demo volume. So I want to delete this demo volume. So that get deleted and that data also get deleted. So if I say ls under root var lib and docker and volumes. So you can see that demo volume directory get deleted because I have deleted the volume. Right. Now, next thing is that bind mount. So now we will see the bind mount. So I have already created that directory. Now I will say docker and container run minus it. Name of the container, I'll say something c1. And here I will use minus v. I can also use mount option. Both the options I will show you how we can use it. And here I'm mentioning the minus v and my directory. My directory is under home, Raman, and my directory. Okay. So this I want to map with my containers directory, say demo directory. And I will use Docker image. Any image you can use. I'm using Ubuntu. So this container C1 get created with the source volume, which is my directory, and the destination path means inside the container, there will be a demo directory. So you can also check docker inspect and C1. And here you can see mount type is bind. This is the source directory and this is the destination directory. And we are having read and write permission. Okay. Now, what I want to do, let me go inside my container. So if I say docker and exec minus IT, name of the container is C1. And if I say ls in demo, so there is nothing. So what I will do, I will create a file inside this. So, so this file is actually available in my directory. See, this file is actually gets stored here. So this is the physical location of my file, right? Now, if I delete my container, so my data should not be deleted. Okay. So let us try that. So if I say docker and rm minus f, my container name is C1. Delete it. Now, if I say ls my directory, see my data is not deleted, right? So this way you can create a container to process your data. Now, if I create another container, so one option I have shown you -v. Another way you can create the container which is pointing to this directory. You can say docker and exec, not exec, docker container run -it. Name of the container, I'll say C1, and I can use the mount option. And here I will say type equals to bind and destination type equals to bind, source equals to that directory, home, Raman, and my directory, and destination is some directory, say demo1, and I'm using Docker image. And if you want to put read only, comma read only, okay. And the Docker image which I want to use is Ubuntu. Okay, my container get created. So it means if I say demo1 right now this time, so you can see I have demo.java file. So it means my data is persisted even though when I delete my container, and I can now point it out to the new container. So these are two types of volume, persistent and non-persistent. In persistent, we are having the data available even though our container get deleted. But in non-persistent, when you delete the container, your data also get deleted. Any question? Do you understand this?
Yes, sir.
Yes, sir.
Okay, but maybe you are able to understand this at this moment, but you need to do a practice, right? So practice is required. So I'll say docker rm minus fc1. Let me share these commands with you guys. So that is all about the storage. Right. So now let us talk about another concept which is called networking in Docker. So let us talk about networking uh, in the Docker. See, consider that you are having one. This is your system. Right? So this is my system, right? And containers, when we install Docker, so basically what happens that there is a network layer which get created on top of my system. So if I go here, so if you want to see all the IP addresses in your system, you can run this command, which is basically IP address. This is the loopback IP address. Every system is having this IP address 127.0.0.1. This is my Ethernet IP address, or you can say private IP address, which is 172.16.0.4. And this is because a LAN card or a virtual LAN card is attached to my Azure machine. This is another adapter which is attached to my network adapter, which is attached. Now, what is this? This is the another process, Docker 0, which is having this CIDR range. Uh, Let me just talk about this CIDR range a little bit. So, okay. So, just a minute. It is coming very thin. Okay. So let me, talk about the CIDR range. Are you aware of CIDR range, Nikhil or Monishika? Okay.
There
So
is
this is,
like classless interdomain.
yes, classless interdomain. That's correct. But what is the purpose of this? Do you know that?
Like it represents that subnet mask and IP range.
Good. Very good. Very good. Yeah. See, so this is basically a networking concept. So whenever we are talking about the uh, networking, right? So in networking, IP addresses is the one which is very crucial to assign to the system. I'm not going in very detail about the networking, but few things we need to know. For example, I have computer one, right? And computer one is communicating to computer two, right? So because they are in network, that's why they can communicate to each other. Now, if we talk about a large scale that you are having in network range, right? So you defined a network, and in that network, you are defining the range. what type of IP addresses I can create. So for example, if I say 172.0 or 174.24.0.0. Okay. So if I define like this, then it is only one IP address, but I want to assign uh, multiple IP addresses. So then what we do, we give a range. For example, here I have mentioned /16. So basically, now what is happening that this 172, so this is, there are 4 octets. So this is my octet 1, which is 172, and my second octet is after dot, which is this. Then my third octet is 0. Okay. Another octet is this, another 0. Now what is this /16? So if it is /16, it means my first these first 2 octets are constant. 16 means 8 plus 8, 16. So it means I can assign, and these I can change from 0 to 255. Right? 0 to 255. So it means 256 and 256. If you see the total number of IP addresses I can create, 256 into 256, right? So which is 65,536. So it means if I use this IP address range, so my IP address will be 172.24.0.0 starting from here. Then another is 1.0, 2.0, and so on 255.0. Then 1.1, 2.1, 2.1.1, 1.2, and 255. So like that, we can create 65,536 IP addresses, right? So whenever you are using this networking concept, right? So we mostly create the subnet. What is subnet? So this is a big network. Under that big network, you are having the small networks. And that should be under this CIDR range. Now tell me one thing. 172.24.1.0/24. Does it come under this range?
No, sir.
Hmm?
No.
Why no? It comes, right?
Yes, yes,
See?
yes, yes, yes. It comes. Yes, yes, yes.
Yeah, because
Yeah, it
24
is
dot,
under 0 to 255, so it is
yeah,
under
so it
0.
will be under 0 to 255. Yes, that is correct. This is 0 to 255, correct. And if it is 24, it means 3 are constant. These 3 remains as it is. And this value gets changed from 0. So how many IP addresses I can create? 256 IP addresses. Now tell me this one now. 172.15.1.0/24. Does it come under this range?
Yes,
No, sir.
so it is
Hmm?
after 24.
So Monishika is saying yes. Nikhil,
No, sir.
It's
why no?
74.
Because we
So
have to make
Monishika, why
constant first.
yes? Yeah, yeah, go ahead, Nikhil.
72 and 24 should remain constant. Then we
Very
can
good.
change the value.
So this
Mm,
should be constant, right? Because
mm,
/16 is given. After that, the values. Now it is 15, right? So 15 means it is not in this. It's a different network. right? So I hope there is a website actually. So um, there is a website, there are many websites actually. If you go to Google and if you search for the cider calculator, so you can go to this any website, right? And you can, I am giving the example of 1624, but it could be, not multiple of 8. So for example, here if I say 172 dot say 24.0.0, and now if I say 32, how many IP addresses I can create? One only, right? 32 means one. And here you can see 24, 256. So if you say I want, so now these calculators are mostly used by the network engineers because they need to decide how many IP addresses we need to assign. So if they require, so they don't do the calculation like I was. There are some complex calculation also, like 27. How many IP addresses? 32 IP addresses. So those calculations, instead of doing by yourself, you use this calculator. So /16, it will be 65,536. So if you increase the number, then the number of IP addresses will be less in the upper range, right? Now, in Docker, basically what happens that there is a Docker 0. So there is Docker 0, which is a network layer automatically get created when you create your or when you install your Docker. So this is a network layer. And this network layer is, is called the bridge network. So bridge is the default network. So bridge network. And it has a IP address range. If you see here, this is the IP address range for this. Right. So there is a IP address range, which is this one. Right. So it means if I create a container, so I'm going to create a container on top of this. So when I create a container on top of this particular Docker 0 network, then it will have the IP address within this particular range only. So by default, this layer is used. Let us see. So if I say history -c, IP address, and now I will say Docker network and --help. So here you can see these are the commands which we can use with the Docker networking. So Docker network ls. If I say Docker and network ls. So what it will do, it will list all the networks which are available for Docker. There is one bridge, there is a host and none. So we'll talk about the other networks, but let us start with the bridge. So uh, bridge is the default network for Docker. Means if we create the containers, they are created on top of the bridge network. And the IP addresses of the container will be in the cider of bridge network, which is Docker 0 in our case. By default, it is Docker 0. Now, what I'll do, I will create a container, Docker container or Docker run also you can write. Docker container is optional. Docker container run -it, and the name of the container I will say C1. And I'm using the Docker image, say CentOS. CentOS Docker container run -it, name of the container. Okay. So this container get created. Now if I say Docker and inspect container C1. So here you will see this is the network section and it is created on top of the bridge network. And here you can see that there is an IP address of my container, which is 172.17.0.2. So this is the IP address of my container. Right? You can also double check with the Docker and exec -it. Name of the container is C1. And if I say IP address command here, okay, IP address command not found. Okay. Okay, so that command is not there in this container C1 because it is using a Docker image and Docker image does not have that command. We can install it, but it does not have at this moment. Okay, fine. Same way, let me do one more thing. I'll create another container, say C2 with the CentOS. Now, if I inspect my container C2, so here you can see it is having the same IP address, right? Not same, but similar IP address, which is within that Docker 0 range. So this is 172.17.0.3. Right? Now I want to see whether C1 can communicate to C2 or not. See, whenever this is my container C1, right, and this is my container C2, both get created on top of this bridge network. So it means they should communicate to each other. Now consider this is your web container. Okay? This is your web container. And this is your DB container. And you want that web application should communicate with the DB container. So then they should run on same network. So now what I will do here, I will say Docker and exec -it, my container C1. I will go into my container C1 and I will ping to this particular IP address, which is 172.70, which is my container C2. And you can see there is I'm receiving the packets, right? So it means C1 can communicate to C2. So by default, the containers, they can talk to each other. Okay. Now, bridge network, very important network, right? Because by default, it is the network. Now, can we create a custom bridge network? So yes, we can create the custom bridge network. Why we are creating custom bridge network? See, for example, you are having a default network, which is Docker 0, and you are creating all the containers on top of that. But now you are having a specific application which you want to run it only on your uh, on your dedicated network. Then you can create a custom network with the bridge network. Let us do that. So let us create a uh, custom network. So what I'll do, Docker and network create command. So I'm creating a network, Docker network create. What driver you want to use? So I want to use the driver, which is bridge driver, means it should be of bridge type. And what is the name of the network? I will say web network. Now there are some optional parameters, like if you want to define your own subnet range. So I will say --subnet. something 192, say 168.0.0/16. So this is my subnet range. And what will be the subnet range, and what will be there is something called gateway. Gateway is the first IP address most of the time. So I'll say gateway 192.168.0.1. So this is my, so I have created one network. Now you can double check that Docker network ls. So here you can see there is a network get created, which is the web network, which is of type bridge. Now, if I want to inspect, so I'll say Docker and inspect my Docker network inspect. And your network name, which is my web network. Right? So here you can see this is the subnet which we have assigned, and this is the gateway. So in case if you want to see it later, so you can see that one. Right. So now I want to create a container. Let me delete my existing container, Docker rm-f c1 and c2. Now let me create a container on top of my web network. Okay. So let's create container on top of the bridge network, the one which we have created. So I will say Docker container run -it. Okay. So what I will be doing, I'm going to use a web application, right? Which is on my Docker hub. So I have created one Docker image by using Dockerfile. So I want to show you a real-time scenario, right? How in companies they are creating web application and how they are connecting with that database. So I have one repository, one Docker repository. So I will use minus name of the container. I will say web container, and I'm using that port forwarding also. I'm saying port 80 is mapped to port 80 of my container, and I'm using the Docker image, which is this one, Raman Sharma 95/web app. Okay, so that is my custom Docker image. Right, so this is created, and right, and right. So I have one more Docker image, and I will name it as DB. And I don't want to do because that is my SQL image. So let us understand these Docker images first. Okay, then we will see how it works. Oh, one mistake I have done. Okay, no worries. I will delete this container. I need to run it on my web network. Okay, so I will delete these containers. So I will say Docker rm-f web and db container. Now I will create those containers again, and I want to run it on top of my, so I need to mention network, web network. Right? Same way, the DB container, also I want to run it on the network, which is web network. Now, if you see Docker and inspect my container web, so you can see the IP address 192.168 because I have given this subnet range. Same way, if you inspect the DB container, that will also be with the same range because it is running on top of the web network, right? 192.168.0.3. Now, let me just show you what is in the container C1. So if I say Docker, if I say Docker and exec minus IT, my container name is web container, right? And Docker exec minus IT web container. And actually, I'm using Apache web server to host my website, and it is a PHP website. And you know, the Apache is basically stores or keep its files under var www HTML directory. So I will say cat under var and www HTML and slash, there is a index.php file I have created. Okay, so this is the file. Now here you can see few things. The server name is DB. So server name is my container name. You can give the container IP address or the container name. So when post operation happens, so let me just show you one more thing here. Where is my I will show this application to you. Okay, so I will take this one and so this is the page which I have developed. So what I want to do, I want to enter the username and the mobile name, means employee name and the mobile name. And when I click on add employee, it will add the record into my table. Okay. So, but in the background, this is the web page. So here, this is the connection string. Server name, which is my DB, because the container name I had given as DB only. Username, this is the MySQL username. So because my web application is to connect with my database, so I had given the name as root. Password, some password, in this case, WizLabs. And DB name is company, means there will be a database called company. And it will have a table called employee table, and the data will be inserted into that particular table when I hit on the submit button. Now let me see my another that container, which is DB container. So if I say Docker exec minus IT and the container name is DB, and here I have installed MySQL. So I will say MySQL and the username I had given root and the password I had given WizLabs. So I'm connected inside my container with MySQL. Now, if I say show databases, so I don't have that company database and I'm using company database. Under that company, there will be a employee table. So I will say create database company. Okay, then I will go inside this company database and I will create a table called employee, and I will create columns, say name, some value 30, and mobile, because that is what my web application is expecting, an employee table. So now if I say select asterisk from employee, right, there is no record. Now I will go to my web application, and here I will say some value. The record created successfully. So now if I come over here, so you can see that that record which I have added through my web page is inserted. So my web container is now communicating to my database container. Okay, so this is a real-time example when you are deploying your application as a containerized application. And this is very common scenario where the microservices or web applications, these are communicating to these are communicating to the database. Okay, so what I have done, I have created a custom bridge network. On top of that, I have executed these two containers, and I have shown you how they can communicate one web application, how it is inserting the data or retrieving also you can do. It totally depends upon the how you develop the application. All right. Now let us talk about the another set of networks. So let me do one thing. Let me remove these containers. Let me delete the network also. Okay. Just a second, just 1 second. Yeah. Now we are having another type of networks, which is host network. Now, what is host network? See, in the host network, basically what happens at this moment, these containers are running on top of the bridge network. But my host machine is also having a network, right? If it is not connected to any network, it is having its own local network. So what I want to do, I want that my container network will be same as the host machine network. Okay, so if you say that my container network is not the default bridge network, instead of that it should have the host machine network, then we are basically using host network. Okay, so how we can do that? So to do that, what I'm doing, I'm creating a container. So now this web application will not be accessible, right? Because now I have deleted that container, right? So this will not be accessible. Now, what I will do, I will create another container, Docker container run -it, and see, whenever you are using the bridge network to access the application, I use the port forwarding. But if you are running on directly on top of your bridge on your host network, in that case, you don't need the port forwarding because everything is running on the top of the host network itself. Port forwarding, why we use? Because containers should be mapped with the host machine. But if you are directly running on the host machine, then no port forwarding is required. So I'm using a Docker image, say Nginx. Okay, I'll give a name of the container also, web container. One mistake, I did not mention the host network. So let me Docker and rm -f web, and let me repeat this, and I need to mention the network also. So I'll say network, host network. Now my container is running directly on top of my host network. So if I run this, see, I did not use port forwarding. I did not mention anything else, right? Simply, I have mentioned network equals to host network. So now my container is using the networking of my host machine, and I'm able to access this. Do you understand this concept?
Yes, sir.
So earlier it was using container networking, but now it's not the container, it's a host machine networking. My container is directly running or using now the port number 80 of my host machine. If it is already in use, you will not be able to access that. Now, if I say Docker and rm -f my web network container. Now, next is the none network. So if I say Docker and network ls, so you can see there is a none network. So if you want to, what is the none network? So in none network, basically what will happen, your container, right? So container will not have the IP address. Okay, so when you don't want the IP address at all for your container, then you can go with the none network. What is the use case? For example, you want to test your container without deploying it on any network, host or bridge network. So what I can do, Docker container run -it. Name of the container, you can give anything. I'm using the network, which is none network. And I'm using Docker image, something, say, send to S7. Right. Now, if I say Docker, inspect, and my container, which is N1. So here you can see it is running on top of the none network and there is no IP address. Now, if you think I need to put it in on the bridge network, for example, you finish your testing and everything, now you want to put it on the bridge network. So what you can do in that case, you can say Docker and network, disconnect. I want to disconnect um, none network for my N1 container. Now none network is removed and I want to connect the bridge network or any other bridge, custom bridge network. So I want to connect instead of disconnect, connect. Now my N1 is running on top of the bridge network. So if I say Docker inspect N1, so now you can see it is running on the bridge network and it is having this IP address. So this is how we are using the networking in Docker. So today I have covered the storage and networking. Let me share these commands with you. Right. So let's wind up today's session here only. Right. So because these are the set of the commands you need to try. And tomorrow we will finish our Docker. In tomorrow's lecture, we will discuss about Docker Compose, Docker Swarm. Right. So those are the two main topics. We'll create a cluster and we will install Docker Swarm on top of that. Any question before we winding up? Nikhil,
No, sir. Clear.
you're fine?
Mm.
Okay.
Yeah.
Manishika?
No,
All right, then we will meet tomorrow. Thank you.
Bye, sir.
thank
Bye.
you.